Another important concept of neurotransmission is called volume neurotransmission. So we are not talking here about just synapses, about classical neurotransmission or retrograde neurotransmission. We are talking about something else. Usually, um, neurotransmission occur within a synapse. But here we are talking about something else. Neurotransmission can also occur without a synapse. This is called volume neurotransmission or non-synaptic diffusion. And by this name, and this figure would actually illustrate that in a good way. So we have two anatomically addressed synapses. So we have this neuron A, and this is another neuron B. All of these this neuron is communicating with its corresponding postsynaptic neuron. This is A capital with A small. This is the presynaptic neuron, and this is the postsynaptic neuron. And the B, the same thing here. The B capital is the presynaptic neuron, is connected with the via synapse, of course, with the postsynaptic neuron here, which is B small. However, so we have this arrow, which is 1 here, this arrow and this arrow would manifest the synaptic communication, I would call it, the synaptic communication, the synaptic synaptic communication, let's just call it like that. Okay. However, there are also receptors for neurotransmitter A, neurotransmitter B, and even neurotransmitter C, which are distant from the synaptic connection. So yes, A small is the right, the postsynaptic neuron A is a possible I would say recipient for neurotransmitters that came from presynaptic neuron A. But also we have these neurons, A small here, but they are not connected via synapse with this presynaptic neuron. But they can interact with the neurotransmitters that came out from this neuron, the presynaptic neuron. But they are distant from the synaptic connection. Okay. If neurotransmitter A, which is A capital here, and neurotransmitter B can diffuse away from its synapse, it would escape this way. Okay. Before, of course, it destroyed or catched by by the receptors here. If it can escape, it will be able to interact with other matching receptor sites, even if they are distant from its own synapse. And arrow number 2 would manifest that. So neurotransmitter would be released here, and it would interact with the synaptic postsynaptic neuron, and that would make perfect sense. It's okay. But we are talking here about neurotransmitters that can escape from this synapse and would interact with this corresponding neuron, but it's not connected anatomically, I would say. And here, of course, on the other hand, I'm not okay. Okay, again. Okay, from A to A, this is synaptic connection. From A here to A there, this is non-synaptic connection, but neurotransmitters can diffuse and interact with this. Okay. If neurotransmitter A or B encounters a different receptor that is not capable of recognizing this receptor, like this, C, for example. So A would not interact with that, even if the neurotransmitters escaped from there or diffuses from there to this neuron or this receptor. It would not interact with that. So, thus, a chemical messenger sent by one neuron to another can spill over by diffusion to sites distant from its own synapse. That's the point here. So neurotransmission can occur at a compatible receptor within the diffusion radius, of course, of the matched neurotransmitter. Okay? And sometimes we can analog that with what's known now, what we use as humans within the communication. Anyways, okay. So by this, you may imagine the brain not just like connection like a collection of wires. No, it's not like that actually. When you understand this concept, you can understand, I would not say fully, but you can improve your understanding about the brain, that it's not just a package or a collection of wires. No, it is actually some kind of chemical soap within a collection of wires, because we are not talking just about the connection between neurons as connected neurons like in synapses. No, we have this diffusion connection that would make things more complicated. So let's just see another picture that would help us here. So this is another illustration for about volume neurotransmission. Here's an example of dopamine and dopamine receptors. So let's assume that this is a dopamine neuron. This is the axon of, and the terminal of one neuron, and this neuron is connected with this postsynaptic neuron. And this would be actually a perfect example, actually, because the example of dopamine, especially in the prefrontal cortex, would make a perfect sense, because there are few dopamine reuptake pumps in the prefrontal cortex. That's why dopamine is available and it can diffuse to nearby receptors, like in this diagram. So dopamine is released from the presynaptic neuron to the postsynaptic neuron. This is this arrow number 1 here, targeting the postsynaptic neuron. Okay, the postsynaptic neuron to this receptor. We are talking about this synapse, of course. But dopamine, if there's an excess of it, and that's usually what happens if there's no reuptake, would diffuse further, of course, in the absence of reuptake pump. So it can reach other dopamine receptors on the same neuron, like this receptor. So here this. So it would diffuse to another receptor, but within the same neuron. Or it can also diffuse to another. It can also diffuses to another neuron, to another receptor of another neuron, like this arrow. So that would be okay also. Let's have another picture for that. So this is another picture to illustrate volume neurotransmission in some monoamine autoreceptors. Here we are talking about autoreceptors. Autoreceptors in the within the dendrites. Let's just take a look at this. So we have autoreceptors, synaptic vesicles, and dendritic monoamines. So what happens here is that, okay, so we are talking about another example of volume neurotransmission. Let's just know about the concept. but the different thing here is that this involves the autoreceptors on monoamine neurons. Autoreceptors, to know them, usually autoreceptors are located on the dendrites and usually also the soma of the neuron. So that would be at the top of the neuron. Okay. And these autoreceptors normally inhibit release of neurotransmitter from the axon of that neuron, and that would be at the bottom of the neuron. So autoreceptor would work as an inhibition if there's anything that stimulate or engage with the autoreceptor that would inhibit the axonal I would say neurotransmission, and that of course thus inhibit impulse flow through that neuron from top to bottom. Monoamines released from the dendrites of this neuron, of course at the top, and then as you can see here, they are released from here. They are released, and then they, as you can see here, they are released, and then they can bind to these autoreceptors, of course, and would inhibit neuronal impulse flow that that may happen if there is no autoreceptor here. This action occurs due to volume neurotransmission, of course, because there is no synapse between these synaptic vesicles and the autoreceptors. There's no synapse between them. It's some kind of volume neurotransmission. The neurotransmitters are released, then by diffusion they they just bind to these autoreceptors, and that's why we talk about it here as a kind of neurotransmission. Okay, so you should know that volume neurotransmission is not just about I would say anterograde neurotransmission, like when you have a presynaptic neuron that releases some hormones to a presynaptic neuron, but presynaptic neuron that release neurotransmitters to in a cleft between to reach the postsynaptic neuron, and some of these neurotransmitters would escape or diffuse to another part of the same neuron or another neuron. This is one kind of neurotransmission, but we have this other type of neurotransmission, of volume neurotransmission, which involve the autoreceptors, and it would work as we said, so just like that.